Hello ma'am, this is Jones. I'm going to do my quality assessment on the topic efficient evaluation of XML queries. Let's see what there is. What an XML. So XML documents have elements and attributes. Your XML is basically, it looks like an HTML code, okay, which has some tags, opening tag, a closing tag, and some attributes for the tag. And inside that, it may contain the data, okay. So it's a semi-structured data. Let's see the next one. Why XML? Database slide. XML is a new way to organize data, okay. Your RDBMS uses tables, but the XML uses ordered trees. Now the HTML focuses on your presentation, the looks, the appearance, okay, but what data it's going to fetch, those things, now it's focused on by the XML part, okay. Next, data management versus relational versus XML. So in this topic we're going to see how the data is managed in RDBMS and in XML. RDBMS is fully structured, okay, so you have the entity relationship diagrams and all, you can easily draw, okay. Each table, the relation is well defined and so on. But in the case of XML, it is semi-structured. It is more adaptable and it's flexible, okay, and suitable for data integration also. It's adaptive, like you can add or remove any data and so on. So XML is actually quite easy. XML is not meant to replace RDBMS. So RDBMS is needed for different purpose, tables, those things. But your XML is a heterogeneous data source, okay. So web services that allow them to talk. So XML is usually used for getting data from a web page, okay. But your RDBMS is used in your local databases or so on, something, okay. Now the document representation language. XML can be transformed to other formats. Example by XSLT. So XSLT, we could transform XML to other formats. Similar, some of the examples are XML to HTML, XML to latex, BibTeX, and XML to PDF, docbooks, and so on. Okay. Data integration and exchange language. So web services, Amazon.com, eBay, Microsoft, they all use XML, okay. Then domain specific data schemas, okay. If your data is greater than 100, you better go for XML. It's good actually. Legal document exchange language, business information language. So it's usually used in the business, okay. Or XML is CNN/lot and blogs. These are all the RSS XML news feeds. Real data having hierarchical structure. Your email header from to CCB. Okay, so in your email you can implement XML. Your header inside this you have the from to carbon copy. So this is a particular syntax of header file. So you can just copy it for different attributes. Similarly, you have a body. Okay, here in the body, your message, your replied mail, everything will come. Okay, network log file. In your network log file, you have your IP address, time, request type, error code, and so on. So it's more of convenient to use these. Advances of translating to XML. So exploit high-level declarative XML queries language. Okay, so that's the main advantage of the XML. Now XML database. Let's see the advantages and disadvantages of the XML database. Managing a large volume of XML data, provide high-level declarative language, efficient evaluate complex queries. XML data management issues, XML data model, XML query language, XML query processing and optimization. So all these can be done using XML data management. And XML data model. Now we are going to see the XML data model. The XML data model is actually a hierarchical data model. It's like you'll have one main tag, and under the main tag you will have another tags and so on. So similarly here, look at this. You have chap, under which you have a data called title. Then you have some free text over here. Then you have another tag. It's like a nested tag, okay. So inside chap you have all this. It's similar to your email. Like you inside one email you have a similar format like header, so on. No? So this is similarly exactly like that, okay. Schema language defines the structures, okay. What we are going to see is Document type definition, DTD. DTD is actually a context-free grammar, structure richer than relation schema and so on. Okay, XML schema is also context-free, richer than DTD because of data types definition. Okay, integer, date, and sequence. These data types it supports, so it's even more better than DTD. Okay, XPath and XQuery. 13 access are there in a XPath. Okay, so some more examples are name test predicates, and you have a sample code over here which I took from the internet. Then you have XQuery, superset of XPath. Okay, so it's a superset, it's a collection of all XPaths, flow or expression. In this expression we have these codes which I got from the internet. Next one, important problems in XML data. How to store XML data, how to efficiently evaluate XPath XQuery language. So these are all the major issues. How to support XML update language, how to support transaction, how to support transaction management, recovery management. So recovery, transaction are some of the important features in the database. So how do we achieve this? So in our agenda, that was just the introduction talk. So in our agenda, we are going to see XML storage, XML path query processing, and XML optimization. Extended relation storage, convert XML documents to relational tables, native storage, that is XML are first class citizens. Okay, then hybrid of relational and native storage. XML documents can be stored in columns of relational tables and XML typed columns. So it's a combination of the both. Okay, and next we'll see. Now we are going to see extended storage in detail. Okay, so extended storage scheme was written by Florence and Cosman. Each node has an ID. Okay, each tuple in the edge consists of parent ID, child ID, data type, preference, and so on. So its advantage is easy to convert XML to relational tables, but the disadvantage is it's impossible to answer path queries such as SQL. So SQL it's difficult to maintain in this extended relational storage. Okay, a path-based storage scheme, XREL. It was found by Yoshikawa. Each node corresponds to a tuple in the table. Each table keeps a routed path to the node. Okay, so each node is connected to as a routed path. It's like a linked list. Okay, to the table. So its advantages also easily convert XML to tables. So you can easily convert XML code to RDBMS, and your con is answering path queries such as the paths. Okay, which you use in Windows, and it needs expensive string pattern matching. Okay, so it needs extended string pattern matching. So the node-based storage, the third one scheme, it was proposed by Zhang and his team. Okay, each node is encoded with a begin and end integers. Begin corresponds to the order and in-order traversal of tree. So it's actually a tree structure. Okay, and corresponds to the order in the post-order traversal. So the advantages are checking parent-child ancestor descendants relation. Since it's a tree, it's very easy to do these things, but inefficient for upgrading XML. So, but if you have to upgrade one thing, you know what we have to do for inserting into a tree. So it's very difficult. It's a large process. Next, we are going to see native storage. So native storage is actually subtree partition based scheme. It was proposed by Kane and Morcott. Okay, a large XML tree partition into small subtrees, each of which can be fit into one disk page, producing approximately an aggregate nodes. Yeah, it's actually a large page. It's actually like a merge sort, like small tree split, but again finally combines. Okay, the advantage is easy to update and traversal. Con is complex upgrading algorithm, frequency deletion and addition, weight Detroit page usage ratio, binary tree based scheme, and it was proposed by Koch. Okay, and convert a tree with arbitrary number of children to binary tree. So for creating it a binary tree, and accordingly we are classifying it. Tree nodes are sorted in document order. Each node has 2 bits indicated whether it has a left or right child. So the advantages are easy to do depth first search. So since it's a binary tree, DFS is very easy actually. Inefficient to do next sibling navigation and hard to update. So those are all the disadvantages. Now string based schema, Zhang. It was proposed by Zhang. Convert a tree to parenthesized string. So here we are converting it to a string, and the tree can be reconstructed by a string. And the advantages are particularly optimized for DFS navigation and evaluation plan. Inefficient for breadth first search. Okay, DFS it's good, but breadth first search it's bad. Next, hybrid of both. The third one, all major commercial RDBMS vendors, IBM, Oracle, Microsoft, okay, they use the hybrid storage. A table can have a column whose type is XML. When inserting a tuple in the table, the XML field could be an XML document. XML documents are stored natively. So your XML storage, it is a combination of the first two which we saw. Okay, let's go for some of the companies that are using. So IBM DB2 UDB, there they use RX XML storage. It's similar to NetX, the second one. Microsoft SQL Server uses blob, binarily large operator data, to represent XML documents. Oracle uses CLOB, character large operator data. So each one uses their different storage types. Next, we are going to see the important one, the XML path querying processing. So extended relation, it has two approaches. Extended relational approach. Okay, here we are translating XML queries to SQL statements. Native approach may be based on extended relations. Okay, so join based approach, navigational approach, and hybrid approach. So regular expression based approach, extend. This was also proposed by Yoshikawa. Linear path expression without branches are translated to regular expression on strings. Okay, so use the like predicate in SQL to evaluate regular expressions. Easy to implement, cannot answer branching path query. So the branch relations are actually difficult to do. So dynamic interval based approach, DI. Use the node labeling interval storage scheme. Dynamically calculate the intervals for resulting nodes, give a path, okay, and so on, those things. Can handle all types of querying including floor expression. Inefficient for answering complex path queries. Okay, merge join based approach, multi predicate merge join, MPM GJL. Okay, this is what happened. This is proposed by Zach. Modify the merge join algorithms to reduce unnecessary comparison. So it basically uses a merge algorithm. Next item for the left input stream starts scanning from the position P. Okay, the native improve MPM GJN algorithm not to look back but all the ancestors in the stack, the previous parent node. Comparing new item, just compare it to the top of the stack. Okay, next one is holistic twig join. So improve the stack based structure algorithm. Use one join algorithm for the whole path expression instead of just one. Reduce the overhead to produce and store independent results. So that's what we are doing in native path. And NATX is also implemented over here because it's this NATX is can be processed only through native path querying. Okay, IBM DB2 extend, they implement this native path query processing. And tree the tree automaton needs two passes of the tree. Okay, and automatically traverses top down and so on. It's like your index. Hybrid processing, blossom tree. It was proposed by Zhang and join based approach, and it's use navigational approach for now sub-expression and structural join intermediate results. Okay, so it uses join combinations to provide the results. XML indexing, structural index. So indexing one of the main components for efficient processing of query. So clustering tree nodes by their structural similarity, by dissimilarities, and so on. Okay, indexing is a graph which vertical is equivalent class of similar XML trees. So each one is connected and index is done using a graph structure. Okay, and amounts to navigational equation. Now we are going to see the optimization part. The query optimization depends on how much knowledge about the data we have, how intelligent we can make use of that knowledge within time constraint, and so on. These questions are answered in this overview. Okay, the cost of a plan is heavily dependent on the cost model of each operator, the cardinalities or selectivity of each operator. Okay, now let's see what's cardinality estimation. Full path summarization, data guide, and path tree. Summarize all distinct paths in XML documents in the graph. Cardinality information is annotated on graph vertices. Partial path summarization, workout table. Keep subpaths and cardinality information in the table. Okay, so this was proposed by Abulunga. What he is telling is actually cardinality for long paths are calculated using partial paths. Okay, and partial paths and additional comparison methods to accommodate the internet scale database. Okay, these are done using the cardinality during the cardinality estimation. And some of them who use these are XSketch and TreeSketch. They implement it over here. Decomposition based approach, XC. XML documents are compressed into a small kernel with edge cardinality labels. Kernel can be decompressed into XML document with cardinality annotations and so on. Okay. Next is statistic learning cost model. Comment. It was proposed by Zhang. Relational operator cost modeling is performed by analyzing the data source. XML operator are much more complex. Statistic learning cost model. Comment. Okay. Zhang. Relation operator cost modeling is performed by analyzing the source code. XML operators are much more complex than relational operators. Okay. Therefore, analytical approach is actually too time consuming. Statistic learning approach needs to be a training set queries to learn cost model from the input parameters and the real cost. Okay, that's it, man. Thanks for watching.